Okay, hey everyone. Part 3 of TDA's game engine. So we're following up after part 2 is looking at getting the input from the joystick or keyboard and then giving those values to this FPC location control container so for a first-person camera, which we can see. Right, so that data comes in right here. So first thing to take account of is that the names that we have for the axes on the joystick here, the default names, y-axis and x-axis, x-rot, y-rot, do not apply to our world coordinates that we're going to be dealing with. So let's just take a look at how we can map those, or how they're supposed to be mapped. And I just made this little cute little diagram here with the controller. So we can see I've kind of placed this within the XYZ coordinate grid here. So we can see the y-axis on our controller is by default, if the angle is 0. So for our purposes, just looking straight forward is an angle of 0. So that's going to move along the z-axis. X-axis on our joystick is mapped to the x-axis in our world. So that's 1-to-1. And then for rotation, rotating up and down here will actually rotate us along our x-axis in our world. So that's y-rot on joystick becomes rx for our world. And then moving along the x-rot on our joystick rotates us around the y-axis in our world. So it becomes an ry, which that is the angle that becomes important for changing our coordinate system and navigating through the world. Cool. Okay, let's go back. Network editor. So once we get these this data in, I've got a little filter set up because my idea was that this is kind of like a drone copter that's flying through the space. So I want it to be kind of like a little bit sloshy, a little bit kind of have some latency in the controls. So there's a sweet spot there of what's actually still workable. And then what we're going to end up with, I'll go over here. So this is the important stuff right here, right? So these are the 5 parameters that I send to the first-person camera in the main container. And to get these values, we go through this stuff. For all 5 of these values, the main structure is a math chop going into a speed chop. So the speed chop is basically a memory that holds onto our current position for those 5 parameters. And then a math, this is really, with our joystick, we're essentially creating a speed for all 5 of those parameters. And the speed, whether positive or negative, is going to affect our speed chop and affect that value that gets held there. So let's take a look. So the easy one here is the ty, because as we can see, kind of in this situation, our coordinate system that we need to really worry about is on the z and x, because as we're flying through our world, that's the way our landscape is aligned. But we have these little bumpers and sliders up here that I've set to be like little hovers, which will take us up the ty and down ty. So to do that, to start off with something easy, so we've got with the bumpers, which go like that, and sliders, so that they're all going through that filter, so that adds a little sloshiness to it. The negative TYs, right, the values coming in are still positive, so if I want it to actually make me go down, I'm multiplying that by -1. And then one thing that all of these maths are doing, actually you can kind of see if I press the slider to the right here, so I should be slowly going up. See, the math right now is 0.3, so it's making my speed go up slowly. So this is what's affecting a kind of hovering up and rising. As I push down here, now I'm going to go back down. Okay, cool. If you recall, let me hit perform mode here real quick, and I'm completely off my path. If I hit the menu, there we go. I've got move sensitivity and look sensitivity. So this creates a different multiplier for that math chop for all 5 of my parameters. I'm going to keep that at 3 for now, but let's get a glimpse at those mults. And here we go. Okay, cool. So in all of these little bases, I'm looking deep into all of this, just like that's kind of a long little script there, but it's essentially looking at my menu overlay. Oops, don't want to do that. And depending if I'm on that move sensitivity, is that on 1, 2, 3, 4, or 5? And so depending on which of those settings I'm at, my multiplier is grabbing one of these numbers from the table, all of which, so for each of these parameters, y mult, tx mult, I've got different multipliers for those, which kind of just took for z. This is highly kind of dialed in to get it to a nice spot. So we can see that mult right here. So that's why I'm multiplying that by 0.3. Cool, cool. And then just another, the filter for the TY there. And that's just going to the end. So I got my X, Y, and Z combining in a merge. And then I also have, for both the translates and my rotates, I've got a little noise here. So this is just a noise, which I can control the amplitude of that noise. That's giving me a little bit of a, just a little bit of a handheld wiggling type of factor. So right now it's on low. Medium wiggle increases the amplitude there. And high wiggle, we can see the amplitude is even more. And let's see what happens if we go back to perform mode here. And I'm like out in the middle of nowhere here. But even not touching anything, you can see now the camera is kind of floating in with variation much more than before. So I find that to be a really helpful trick. I'll just keep that on low for now. Just inside there, I've just got a little panel with a filter and a math there. Nothing too crazy. Okay, so let's look at, I guess also on the easy side, let's look at the rotates, and then we can get into TX and TZ are going to be the difficult part that involves a little bit more math. For the RX, which on our controller, you might recall, is the Y rot, so going up or down. That is pretty easy, but I've built in a little invert in the menu as well as right here. So if we click invert Y-axis on the menu, that essentially turns this on or off, which is just adding, a negative or positive to how this factor is multiplied. And one curious little thing I have going here. So if my rotation is roughly 0, which means I'm looking straight forward, and then as I look up, so that would be positive. You can see my speed went positive there. As I look down, it gets into the negative on my speed here. Crossing that line from positive to negative presented a problem when I do this little filter, because everything is kind of like slowed down and there's a latency to everything. And I've got this modulus operation, so it's being clamped essentially. It's looping between 0 and 360 degrees. If I did not do this, let's do this right here. On my filter, at a certain point, as I change this a little bit, I'm going to go from 360 back to 0, which presents a problem with my filter and just the way all these kind of values get get applied to the camera. So this is like a little trick. I'm just adding 180 right here, kind of going through all of that, going through the filter, and then at the other end, I'm subtracting 180 before I send it to the camera. So it's kind of a little hacky trick, I think, but it works. So I'm fine with that if you are. For RY, that's pretty simple. So this is the X rot. So same deal, right? So my joystick value coming into the math, it's being got a mult from my sensitivity settings. Speed is holding on to that. Expression, whatever number this is, I'm just modulus is keeping that within a 0 to 360 range, a filter, and then just sending that there. So I'm sending the RY all the way to the end here. But then RY is what I need for my X and Z calculations, which we can see right here. So this is where we get into this formula. So this was exactly what I had just copied and pasted from a Stack Overflow question. You could see this math formula for first-person 3D game. This is from quite a few years ago. These values don't match what we're doing, actually, because it's kind of expecting a normal like Cartesian grid where you're looking at X and Y, but we're not looking at Y at all. We're looking kind of from a God's eye view, right? We're looking at X and Z. So these are kind of shifted, and it's not quite clear what this WT, WC, what all that means. It kind of refers to the camera and the world. So let's look at this a little differently. Let me split this. And I'll keep that there for now. And I love just spending too much time to make cool graphics. So let's do a top view here. Okay, so is this going to work? Awesome. So I've got a simplified version of my system here. You can see the angles here correspond to, let's go see the RY. There we go. There's my RY for my system. We can see the angle right there. Beautiful. And so this is a kind of a rewriting of that formula that I just showed you, but more in the language of what we're actually doing for this project. So for the first one, I need to find, if it all kind of depends on these maths, right? Let's actually put these together. Let's do our Z's and our X's. Kind of right there. Let me make a little room there. Okay, so there's my X position, there's my Z position. I'm not moving, so the speed is 0 right now. You can see in our math. I need to find out, depending on what my angle is, how much of my speed is going in the X-axis and how much of it is going in the Z-axis, because I need to know how much to affect these two speed chops, right? So to simplify this, what if my angle was 0? And I'll get this okay, pretty good. So we can kind of think through this as a thought experiment. So now if I hit my forward button here to move forward, I think I should be moving completely in the Z-axis and not moving at all through the X-axis, right? Because I'm facing straight forward on the Z. So let's test that out. If I press forward. Oops, I'm like blinking here. Do it again. Cool. Okay. And we can see as I hold forward, I'm actually moving almost -1 in the Z, which is what I should be. In the X, I'm not quite at 0, so it's just a little teeny tiny little bit of movement on the X. But you can see here I'm moving pretty fast on the Z and not so fast in the X. And that is what it should be. If I hit backwards, right, that'll take me in the other direction. So that works. Okay, cool. If I did the same, let me make my angle 90 here. You can call up your high school trigonometry teacher and say, I'm using trigonometry in my life. It's wonderful. So now I'm at, that's roughly 90. It's close enough. So now if I go forward, all of the movement all the speed should be in the X-axis, right? And lo and behold, It pretty much is, because I've got a little mult happening on that, which is slowing it down a little bit, but cool. Go backwards. Okay, that works. So that is proof that math works. Okay, close it. Great. So speed chops are holding all those values. And what else is happening? So when just my x-axis, not to forget about the x-axis, this is kind of doing the kind of thing like a strafing, just going side to side. So it's feeding into my x and my z formulas here. But I also have a little thing that is creating a little roll, which I'm grabbing that in my window roll parameter in my camera. So let's just take a quick look here. Let's go to main. There's my camera. And we can see this is grabbing using absolute path here, going into my container, the thing called X forms. I'm grabbing the TX, TY, TZ, RX, RY, and then in my view, there we go. So there's my roll. And I think actually I also multiplied it a little bit more there because whatever, that's what I felt like doing. And then we have, that causes the little, kind of a little roll happening when I move just on the X back and forth. Okay, cool. So what else is happening here? That's the math content. But let's look at this jump location. This is really going to make more sense. In the next video, we'll get into zone tracking and making what I call these milestones. But let's actually do this. Let's get lost. Let's just kind of, okay. If I go off into space here and can't see anything, after a couple seconds, it'll say press Y to return to path. And let me see first. Let's look at our zone tracking for a second here. I can tell right now I am closest to milestone number 203 because I can see that's this lowest distance right there. And thus, if I go to row 203, I'm going to have a certain, I can't count to 203 here, but take a guess. I've got TX, TY, TZ, and RX, RY in this table in all my milestones. So in my location control, I also have that situation. So what I can do is if I hit, I'm lost. Okay. So if I'm lost. The lost beacon is what I'm calling it, is saying press Y to return to the nearest path or whatever. Oh, look here. I've got that right there. I've got closest milestone, which I'm grabbing from my zone tracking. And so I know, okay, I need to jump. That's my jump location. I need to jump to row 204 in my milestones table. So if I'm lost, which is now true, so this is 1, and I hit button 4, which is the Y button, both of these things will be true. My logic is an AND here. And so then what happens? I click button 1. That's button 1. So that lost click A. Okay, great. And then I multiply 1 by 204. So the number 204 comes out of here. That overrides this. And don't worry about delay. So the number 204 goes into my chop execute dat. And that val, so that's essentially saying look at row 204 in the TX column, TY column, so on and so forth. I'm applying these variables to that. And I'm setting my 5 speed chops. I'm setting their reset values. Cool. Okay, so that's how I'm actually moving around. I'm kind of like jumping to different locations. If we just go, whatever, let's do like a TX here. You can see right now the reset value of this TX is like 20.027. If I were to reset this speed chop, it would jump to that value. right? Boom. Okay, I just hit reset. It jumped to that value. So, okay, if I could change the reset values for all 5 of my reset value parameters for my speed chops, and then pulse the reset of all of them, I will be able to jump to whatever location I want to jump to. In this case, okay, am I still lost? Let me get lost again. Okay. And let's see what happens. Let's do this again. Okay, now I'm closest to 201. And let's just have a look at what happens with our TX here. So when I click this, reset value is going to change, and then we are going to get this pulsed. There we go. Okay, I hit Y. That was changed to whatever that milestone is, and then everything got pulsed. And now I'm at that location. Proper TX to YTZ, proper rotation. And that's how we're kind of teleporting and jumping to certain spots around the whole world. Finally, let's turn on sound, because there's one other little trick with the sound that is highly related to my navigation through the world. And I'm in black hole, cool. And let's just look at drone copter. And let's just turn that up. There we go. So the drone copter is this kind of drone-y ambient thing, and I've got 2 versions of it. Actually, let me what I should do. I'm going to go back to the beginning. It'll be a little clearer to see. Restart. So I just jumped back to my milestone number 1. Okay. So as my speed changes, so I've got my translate and rotate stuff coming in here, and you can see as I move, got different stuff happening here. I'm getting a kind of overall speed, both rotational as well as my TXTZ. Depending on my speed, I'm sending a kind of a gain signal to 2 different audio files. I've got one that is just a plain, more kind of drone copter sound, and then one that has a tremolo effect to it. It kind of adds a little fluttering. So as I move through the space, we can see these values change, and then the sound will change. So this is the tremolo sound, that's the no tremolo. It's a little subtle, a little bit more of a flutter. And then no flutter. So little kind of subtle acoustic effects also are tied not just to whatever zone you're in, but just the speed and a lot of other factors. Okay, so I think that's good enough for today. Hopefully you enjoyed the math content. And next time we'll look at zone tracking. Cool.